we are on. Welcome, welcome, beloved siblings. Here we are we are the Brain Buddies. I'm Aaron Freeman. That is Peggy Mason. I'm checking to make sure that everybody else can be on. Anyone who wants to be on and wants to talk to us can. We are the Brain Buddies. We are here on Facebook at the Brain Buddies, Chicago Brain Buddies. That's us. We're Chicago Brain Buddies. I'm just making sure that we're broadcasting on. Yes, we are. There we are. All right, good. So my buddy Wilton Mittman is there on the line here. We got Will. Will, we love you, Will. Welcome. So, boss, Professor Peggy Mason, neurobiology professor of the University of Chicago and NeuroMOOC, and, if I may say, the author of The Brain is So Cool, my absolute favorite neuroscience blog, thebrainissocool.com. Check it out. Okay. Hi, boss.
Okay, so we're going to talk learning. And
Learning.
We're going to quiz you.
I got learning. I own learning. I know everything. I got it nailed, girl. Nailed.
Okay,
All right.
Aaron, where does learning happen?
I will tell you right. It happens inside a little part of the brain right near the temporal lobe that's shaped like a seahorse, the hippocampus. That is where learning, the hippocampus is where new information gets integrated into long-term memory, and that is what we call learning. Thank you very much. And can I just mention one other thing in case you may not have known this, you may not know this, but when you learn via your hippocampus, you create brand new brain cells.
Oh, is that what happens?
What?
Is that what happens?
That's exactly. Well, of course, is what you might not understand this, but I took the Peggy Mason's NeuroMOOC class, so I understand these things.
Okay, so does learning happen anywhere else?
Well, why would it? No, it's the hippocampus. It goes. Weren't you listening? The hippocampus converts short-term memory into long-term memory. You're not paying attention here. I can see this. I mean, but you're still a good person, so we'll grade you gently.
Okay, so let's say that you learn how to ride a bike.
Oh. Yeah.
Let's say that you learn how to draw in a mirror. So you have to trace something, but you can't look at the paper. You have to look at the mirror, and so your hand has to go opposite from what you're seeing your hand as. Okay, that's called mirror drawing.
Okay. Yeah.
Now, if I give you mirror drawing and you try it once, you'll be okay. And then if you try it twice, you'll be a little bit better, and you'll get better and better. And that's called motor learning. Is that happening in the hippocampus?
I'd like to believe, for purposes of this conversation, I would like to believe it does, but I got a bad feeling. I have a very bad feeling that you're going to tell me something that I won't like.
Yeah, so motor learning we think it happens in the cerebellum.
Yeah.
Okay, so let's take another type of learning. What happens if you eat something really, you think you really love it, and you eat it, and now you throw up, and now you never want to see this again, and when you look at it, you feel very yucky. You don't even remember. This happened when you were 3 years old. You don't even remember it, but it gives you a bad feeling every time you see pineapple. Okay, this happened to me. I have a thing about pineapple because I threw up after eating pineapple. So every time I see pineapple, I have a bad feeling. Did that happen in the hippocampus?
Well, okay. Well, wait. So,
let me say, Aaron, I have to say one thing, which is it's incredibly entertaining to watch the wheels go round.
Well, I'm thinking there's got to be something, some way that this is right. But wait, okay, but wouldn't am I wrong? Doesn't the hippocampus convert isn't it involved in converting short-term events into long-term memory?
Certain types of short-term memories into long-term memories, yes. Certain types of working memories into long-term memories. Things that are declarative, semantic, episodic, knowing where you are, things that you could explicitly say, I know that the 44th president was Barack Obama. I miss you. Uh, so those what are called explicit or declarative memories depend primarily on the hippocampus.
Okay.
But
when riding a bike, but why wouldn't I remember? Why would my hippocampus? I mean, so I try to ride the bike. I shake around, but somehow I sort of figure it out. But that doesn't make any sense because I suppose you're going to say that's one example of that being different from semantic memory is that you basically don't forget stuff. You're going to tell me, first of all, that bicycling has to do with the hippocampus. I mean, the cerebellum. And the cerebellum, all right, so we all
there's more examples. So these emotional memories,
right?
Any clue? Where do you think those happen? What do you think the primary places for them to happen? So what we think of the primary places is amygdala, not hippocampus. You know, hippocampus has a nice neighbor.
Wait, but they're connected. I mean, they're connected. The hippocampus is connected to the amygdala, huh?
Indeed.
Right.
We don't actually need the hippocampus to make an emotional memory. So the kind of memory that's involved in, say, post-traumatic stress disorder is thought to be made within the amygdala, or that's a primary place where it's made. And I'll give you one last example.
Okay.
Let's say that all of a sudden something hurts like hell. You bang, you break your arm, you cut your arm, and then it recovers. Are you getting feedback?
I'm not. I hear a little of yours, but it's not terrible.
Okay.
I want to ask if anybody can you guys hear? Are you anybody having trouble hearing Peggy on this? There are a couple of folks who are listening. If you are, let me know. Anyway, go ahead.
So, let's say you break your arm, and then a month later you find that your arm still hurt, or a month after it heals, you find it still hurts. You have converted from pain, acute pain, to chronic pain.
Okay.
That conversion is a learning process. Any clue where that's going to happen?
Well, I'm positive it's not the freaking hippocampus. I'll tell you that right now. There's no way. The hippocampus is just barely involved in learning. I don't even know why you brought it up.
So we think that it happens at least in part in the dorsal horn of the spinal cord. So
the back part of the part facing out.
Correct. Okay. And so what is common to all of these various amygdala, cerebellum, hippocampus, spinal cord? They share one thing, which is the mechanism. And tell me again what that mechanism is.
I don't remember. Hippocampus?
How do you do it? I think you mentioned some new neurons.
Yes. New neuron. Well, so what I think now I've gone back to my humble maybe this is the right thing. Does it really have something to do with stem cells?
So no.
Okay. So
neurons are not useful cells in and of themselves, right? What makes a neuron super cool? What gives a neuron its power?
Its ability to communicate with other neurons.
Yeah, its connections.
Okay.
So what is learning? Learning is changing the connections between two neurons. So neuron Joe says to neuron Jane something, and neuron Jane just ignores Joe. Jane is ignoring Joe. Joe just blah, 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 blah. Jane says, yeah, whatever. And now in comes Sam. And Sam and Joe are now going to shout at Jane together. And now all of a sudden Jane says, oh, okay, I'm actually going to listen to both. When they're talking, I'm going to listen to them. And so that connection gets strengthened. That's learning. It's going from a connection that was very weak to a connection that's very strong, or from a connection that's very strong to a connection that's very weak.
Now, okay, this is exactly because Sharon, the great love of my life, had this. I think you just answered what her question was, but let me say, we are the Chicago Brain Buddies. We're on live. If you would like to type it, if you're at Brain Buddies, Chicago Brain Buddies on Facebook, or if you're at Peggy Mason's Facebook page or Aaron Freeman's Facebook page, please feel free to join in. We'd love to hear your comments or questions. Okay, so what Sharon, you just now said is that learning occurs when new connections are made between neurons.
The connections, what we found out for a long time is that the connections are there. They're just quiet. Okay? So they're silent. And all they do, so you can think about turning the volume. And in this case, the volume can start at 0. There's an anatomical connection, but Joe is talking and Jane isn't hearing anything.
Okay.
Even though they're right there.
By the way, you're making a point that I think is just worth mentioning, that the neuronal connection, the neurons never touch each other, but they're really close. And so just even though they're connecting and they're communicating, they never physically touch. But anyway, go ahead. I'm sorry.
Going back to what we talked about last week with Cahal, who managed to figure that out without actually seeing it, because he couldn't see it because his microscope couldn't show it to him.
I understand.
I mean, these are cool things. Anyway, so
Jane is talking to Joe, and Joe is talking to Jane. Jane is not listening. She's just ignoring this poor little neuron.
And then something happens that makes Joe think, or Jane think, well, maybe what Joe has to say, I should pay attention to. Maybe because Joe says the same thing as Sam, and I like Sam, so I'm going to listen to Joe because Joe and Sam seem to be saying the same thing. So I might as well listen to Joe as well. And so now all that happens is the same connection is there, but some different molecules come in. These receptors come in. Jane's going to put some receptors here so that she can listen to Joe. And now that's going to strengthen this connection, the connection that we call a synapse.
Now, what Sharon wanted to know was, when a connection is one neuron begins to pay more attention to another neuron, is its connection at all weakened to other neurons, or is there
not necessarily? No.
So is there an unlimited number of connections that any given neuron can have?
Is there? So the neuron's going to have a lot of connections, and that's going to be relatively stable. It could change. You could add or subtract synapses, but in general, the synapses are there, and the strength of the synapses is what changes.
Oh, okay. So you don't
lose strength.
Okay, so you don't lose. So they're the ones that are connected. So you can't connect like to a distant neuron somewhere far in a brain region far away.
Right. You're right. And so, can you strengthen all the synapses? I mean, if you, at a certain point, you strengthen everything, and now Joe's voice has no meaning anymore. If you strengthened all the synapses, all the connections, all the individuals talking to you, then any one individual has no impact. And so it brings up a very important point, which is that just as important as strengthening synapses is, just as important as remembering things is, or putting them into long-term storage, it's also important to forget things. So if you can't forget...
Wait, why would I want to forget anything?
Because otherwise everything will build up, and all of the, so let's say a neuron gets 10,000 inputs, okay. 10,000 synapses, and that's a reasonable number of synapses for it to get.
For one neuron?
One neuron can get 10,000 inputs. And let's say that it increases the strength of, say, 200 of those. Well, that packs a punch. But if you increase the strength of all 10,000, then it no longer has any impact, because now they're all strengthened, so no one's stronger than anyone else. Okay. And so over a lifetime, you're gonna strengthen Joe and Sam and Rachel and Rebecca and Abraham, and you're going to strengthen them all. And if you don't eventually weaken some, you'll have no ability to strengthen further new ones. So we have to be able to forget in order to remember. And that is the way it works. There is a way in which you put molecules, you put these receptors into the receiving end of the synapse, and then after a while you take them out. If they don't get used, if Joe is yelling with Sam, and Jane has decided that she's going to listen to Joe, and then Joe stops talking for 5 years, well, Jane's going to say, okay, well, I got better things to do. I'm not going to listen. I'm not going to wait for Joe to talk again.
Now, wait a minute. So our boy Friedrich Nietzsche says the existence of forgetting has yet to be proven. We only know that we cannot always recall things when we want to.
Well, I would say that Nietzsche, despite Nietzsche's claim that the neuroscience community believes that we have these two opposing cellular processes, which change the synaptic strength in one direction when things when learning is occurring, when two things are associated, for example, and then change it in the opposite direction when those when they become dissociated, when you extinguish that connection.
But that seems to be that view that some things you just forget is really close to being counter-experiential. Did you ever see the movie Ratatouille?
I love the movie Ratatouille. I've seen it. I don't know how many times I've seen it.
But you know what I'm going to say? You know what I'm going to talk about?
No.
Remember when the food critic tried the Ratatouille? The food critic, the mean, evil food critic, comes to the restaurant. He tries Ratatouille, and bang, he's back in his mother's cottage in a little village in France. I mean, stuff that in my experience is, and my guess is yours too, that you'll hear a smell, you'll smell something, or hear a sound that'll go bang, and something you haven't thought about in literally decades will become crystalline. So
no, absolutely, and so memories have different strengths, and so the memories that have a big emotional impact, and the ones that are older, and so they've been, it's as though you've recalled them over and over again. You've strengthened that, essentially that rut. You have a rut, you have a channel between the input and the memory. And those really strong memories are the very last to go. If you watch somebody who's losing their ability to make memories, they lose it in a backward fashion, retrograde. So you lose the most recent ones, the ones that you've recalled the fewest times, earliest, and the last to go are the very emotional ones and the ones that are oldest. But on the other hand, do you need to remember what you had for lunch 6 days ago?
Well, it is unlikely that I will ever remember my daughter's phone number. Like if I knew it once, but there's a picture on my phone. Actually, I don't know your phone number. I've never even learned it.
I can tell you, I remember my phone number from being a kid. So my phone number from when I was a kid, I could tell you that right now.
I remember that.
301-365-3888. Okay, that was my phone number.
So no, I'm not a complete.
But actually, it was funny because I was filling out a form the other day, and it asked for my address, and I got a little bit I had a moment of uncertainty as to what my address numbers were, and I had to look it up on my phone.
Ah! Okay, so why
that has low emotional impact. My address has very low emotional impact.
But you have a very good semantic memory.
I have a good enough, yes.
Oh, yes, okay. You give me good enough to be a professor of neurobiology at the University of Chicago, okay? By the way, this is Peggy Mason, professor of neurobiology, University of Chicago, at NeuroMOOC on Twitter, and please check out thebrainissocool.com, her blog. So, why do I think that the hippocampus is the seat of all memory? Where did I get that notion? Where did I get that wrong impression?
Do you remember HM? You remember the story of HM?
Wait, who? HM? Who's that?
You tell me who HM is.
Henry Morrison was the very kind, very gentle man who had severe seizures, and in his treatment for those seizures, his hippocampus on both sides were removed. No, his hippocampus, yeah. His hippocampus.
Well, actually, they removed pretty much the medial temporal lobe. It included the amygdala. It included entorhinal cortex. It was a big lesion.
Yeah, and so after that, he had what they call anterior great amnesia. He could not form new memories. It's sort of like it was the conductor Clive
Waring.
So that he lived in this 10-minute segment of time. And when he expressed himself, was a fully wonderful, charming human being within that 10 minutes, but anything further than 10 minutes in any memory, he had made no new memories.
So it's really, really interesting that you should bring up Clive Waring. And I think that we're gonna have this for maybe next week's discussion.
Great.
But something for the viewers to think about is the fact that Clive Waring, and you can watch this on YouTube, he had essentially working memory, but he couldn't convert anything to long-term memory. So what would happen is that he had a notebook, and he would write in his notebook, "I just woke up. I think it's been forever. I haven't seen anything, heard anything, smelled anything for forever. And I just woke up." And then he'll scratch that out and he'll say, "I just woke up." And he does this throughout the day, and he rages. It's just, he's tormented by this.
All these other entries are wrong.
That's right. And then he'll ask his wife, "How long has it been?" And she'll say, "It's been 9 weeks," or whatever, 9 years, because he's still alive, actually. And he just can't comprehend this. And instead of being HM, Henry Mason, HM was a very kind of easygoing kind of guy, and he flowed with this, but Clive Waring just rages on it. It is so incompatible with who he is. And so what I want to bring up is that there's another individual named Lonnie Sue Johnson, who I just finished reading a very interesting book about, and she has a condition very similar to what Clive Waring had, and she has yet a different reaction. She's extremely talented, but she's extremely good-natured. So she just says, "Oh, hi, would you like to see my drawings? Would you like to see my puzzles?" And she's just outgoing and engaging, still very much the same person she was before her illness. But what this tells us, what's very interesting, is that same basic problem, 3 different reactions. Now, what is the reason for these 3 different reactions? Part of it is that they were different people beforehand, and part of it is that the lesions may not be exactly the same, and part of it is that we may have oversimplified the lessons that we think we've learned from HM. And so that's what I want to put that out there. That's what we'll delve into more next week.
Just tell me, we may have oversimplified the lessons. What do you mean by that?
So in other words, HM, when he was 27, plus or minus, when he got the surgery. And he'd been having seizures for 20 plus years. And he was not good at anything. He stocked shelves was sort of the height of his functionality. He graduated from high school very late because he was incapacitated by these seizures, and his mental abilities were also affected by these seizures. And in contrast, Clive Wearing is an incredibly accomplished conductor, musician, and Lonnie Sue Johnson is an amazing artist. She made covers for the New Yorker, many covers for the New Yorker. She also was a pilot. She owned 2 of her own planes, and she lived in upstate New York, and she built herself a runway, and she'd land her planes on her runway. She had a lot of accomplishments, a lot of abilities. And so they come into it very different. HM didn't have a lot to go on.
But can I say, though, that
we may have sort of simplified our understanding of what the hippocampus is really doing, because we overemphasized HM as the quintessential example of a hippocampal lesion. Now, there are reasons that may not be so. There are reasons that it may be so, and let's talk more about it.
But let me just say one thing that I think is worth noting, that both, in my view, and I don't even know if this is what I'm about to say is true, but my impression is that both HM and Clive Wearing, what survived was their capacity for affection, or as you might say, prosociality. That Clive Wearing always loved Deborah.
Right.
No matter what, he always, and my understanding is from the woman who told the HM story, that he was always kind, even though he never didn't remember her, he was always kind. He was always willing to talk to her and participate in her little experiments.
Yeah, they reform. They show their quintessential personality. I don't know if you know, I had a friend, my spouse and I had a friend named Carol. I've written about her on my blog, and she died at 102. And around 95, the memory, she really wasn't so good after that. But she always, until the memory got really, really bad, she stayed the same personality. And so even though she couldn't remember anything, she's still fun to be around because she had a great personality. Yeah. So one of the examples for what the hippocampus is thought to be responsible for, we had I don't know if I told you the story, but we had a 25th anniversary party, and she was invited, and we had a book so that our friends and family could write in the book. And she wrote in the book, and she I can't remember exactly what she said, but something really nice. And about 3 pages later, she wrote the exact same thing. She just didn't remember.
Sharon wants to know, once the connections that form a memory are disconnected, do they have a predisposition to reconnect? If I'm drawing or writing about a situation I barely remember, as I work on it, more details emerge.
Right.
Were they all along, or did they reform on request?
So it's not that they disconnect. Remember that it's not a disconnection. The connections, the anatomy is still there. All that's changing is the strength. And if you've been strengthened before, it does appear that it's easier to re-strengthen. Okay. And also you're pulling in lots of associative memories. So lots of different, in any one scene, there's 15 different sensory cues. There's the lighting, there's the color, the edges, the sound, the smell, the feel of it, the temperature of it, et cetera. There are all of these different features, and all of them are sort of being tickled by this a situation that you barely consciously remember, but the tickling adds up to something that actually can help you recall the whole gestalt.
So to wrap this up here, we don't create new brain cells when we learn new things?
Well, we may create new brain cells. In general, that stops around age 5 for humans. So mice and rats are good at that. See where it got them.
Yeah, in your lab.
Sorry.
In your lab, running around getting caged up. That's what happened.
That's the nastiest thing I've ever said about a rat. I feel badly. Bad me. But
okay.
But you know, we don't make new neurons, and we certainly don't make them in the hippocampus. And they are not responsible for memories, and they are not responsible. One of the things that we have learned in the rodent is that it appears that new neurons in the hippocampus are integral to the actions of antidepressants on rodents. But that does not appear to be, that could not appear to be the case in humans, because we don't make those new neurons.
One of these days, I'd really like to understand about the antidepressants on neurons, on rodents. But anyway, so let me thank you. Thanks, Sharon, for commenting. Thanks, everybody who's watching now. Thank you to everybody who'll be watching later on the World Wide Web. I am Aaron Freeman, the artist in residence with Chicago Council on Science and Technology. That magnificent and beautiful creature is my pal, Peggy Mason, my Chicago brain buddy, a professor of neurobiology at the University of Chicago, at NeuroMOOC on Twitter, and her blog, her fabulous blog, The Brain Is So Cool. We'll put a link to it down here and a few other links. So thank you very much. We'll be back next Thursday. Peggy, you totally rock, and have a great weekend.
Thanks, everybody. Bye.
Bye.